Welcome back to my Ford Transit Mk8 Campervan build, and this looks like I've gone back in time a bit, but actually I've been up to a lot and we've got busy episodes. We're going to get all of the painted cabinet carcasses in, then we're going to reinstall the sort of updated layout for the electrical system and the lithium batteries and all the safety precautions for the lithium batteries. So quite a busy episode. So let's get cracking. Well, those are bright. This isn't just orange, this is Moroccan Sand 1 orange. But no, I'm extremely happy with the colour. Not to everyone's taste, I suspect. So at the minute I need to get all of these square up with the floor again. And well, sort of mount them in finally, really. Right, this was the electrical board which used to be sited up in the cupboard and it's getting moved. Lucky for me, if it's perfectly still on the inside of here, so I'm just going to rebuild it and I'll give it a nice coat of paint, so it's kind of come to rebuild it. As I was quite lazy in the way I disassembled it, everything should fit back together quite nicely. Right, that's the electrical board. Redone. I'm pretty happy with that, looks pretty nice on the white background. Right, it's time to get installing the used lithium batteries, and you've probably seen from the other videos, I've got 3 used Valance U27-12XP lithium batteries, and I've got their 130 amp hours at 12 volt, and I'm going to be running those in parallel. Just like when I put the AGMs in, I need to combine all the positives together and all the negatives together, with the main positive coming out of the one battery and the main negative coming out to the other one. I've got 2 at the bottom of this cupboard and a hole through for the third one over here. But I do have to make sure that all of these lengths between all the wires are the exact same. It's really important to do that. So I'm going to start making some of them battery cables with 25mm 25mm cable, funnily enough. So for anyone watching who hasn't watched the other video, this is 25mm squared high flex battery cable. For the American viewers, I'm not sure what's in your American wire gauge system, but there's easy conversion charts online. So all I'm doing at the minute is just taking off the end ready for the lugs, and then I'll get them all made up. So these are 25mm squared to M8 bolt lugs. They may look confusing when you've got loads of them, but it just says in really small letters there. So all I need to do with them is put them on the end of the cable, make sure I've got them all nicely positioned. So I've got a set to 25mm. This is just a cheap crimper off Amazon from China. Just an alright job. Just because it is quite a cheap crimper, I do test that it's actually worked. Slide some heat shrink on before I do any more. Definitely worth, if you're going to be doing this, is getting yourself a heat gun, and they're pretty cheap. Like this was like, this is a 2000 watt one, and this was £9.99 from Screwfix, so a bargain for a tenner. Alright, battery cable's done, let's let them all cool off. So I need to get my newly revamped electrical board in. So this is the main power wire, which I still need to cut and adjust, and this is the main fuse, which is going to go for the main positive, which is this one, so we're going to mount that up there. Right, so just going to remount the shunt in its new position and then make up its appropriate cable. Also need to remount the main fuse as well. Right, we're almost back to where I was a few weeks ago. Just get this bit mounted. So now that that's there, I need to rewire up the battery to battery charger and the fuse box and bus bar. So this bit here is going to be my new cableway leading from here and then the old cupboard. Well, just for this wiring process, since I've got 4 cables, 2 of which each look the same, I'm just going to wire them up, label them up, so I don't end up wiring the wrong thing. The other bits have not had the best view. So we've got the shunt back in, the main fuse, and I'm going to wire, they're coming in here, so I need to wire them around here and into their corresponding bars and applications. So something I've mentioned is because these lithium batteries are used, and if you look back at the videos I did about them, that although they have battery management systems internally which can manage the cells in each individual battery, they can't perform any of the cut-offs which say a true battery management system could do, such as if the batteries are too low and get too discharged, that can damage them, so other battery managers would disconnect all the loads. And same for overcharging, so if for some reason one of those chargers was putting out a lot more power than it should, that can also damage these, so you need something to disconnect your chargers. And also these batteries don't like to be charged in low temperature environments, so if it was below 5 degrees it would potentially damage them if you started charging them. So I need to integrate those systems into my electrical system. So the main way I'm doing it for the low power, for the under voltage, for the drain, is using a Victron Smart Battery Protect. I'm using the 100 amp model. I'm going to sight that there, and what that does, that's going to go from my main positive bar to the unit, and that goes up to all the DC appliances. So if for some reason, let's say I left something on and I drained the batteries for a preset voltage, when these are becoming drained, this would disconnect all the loads which are at the other end of it, preventing it from discharging anymore and preventing damage from undercharging. But this device has to be used correctly, and quite often you see them installed incorrectly. They don't allow reverse current. Power can only go one way, so in and out, so power can only come from the batteries, go through the item to the DC appliance. The reason I couldn't have this elsewhere, say on this part of the wire, because reverse current would be the batteries pulling current through this item, opposed to appliances pulling just through it. You can't have the batteries pulling energy through it, only energy can go one way. It's a directional item, energy can't go one place. So I'm putting it somewhere where there are no charging, no power's coming into the system, so power's only going out. I'm probably going to mount it about there. So that's going to protect me from the under voltage, so let's get that sorted. Something I will just mention, these, they are directional, so if you had this at the end of a charger going directly to the batteries and no DC loads are being drawn through it, it'd also work that way. You just can't have it going both ways. I think I'm going to locate it right about there. Right, let's make up this cable here. So since I can't connect this up today because I don't have any 16mm to M8 bolt terminals, that's an M6 bolt terminal, I've got plenty of those, but I don't have any M8 ones to make this cable or to attach it to there. So they're on order and they should arrive tomorrow, but I can connect a bunch of the other bits up. So I could start looking at connecting the main negative bus bar up and reconnecting the battery to battery chargers. Right, I'm just going to rewire this bit without the camera because the camera has to be there and I can literally not get in this cupboard with the camera there. So I'm going to turn you off for a bit so I can actually get some wiring done. So I'm going to reinstall the BMV's battery monitor up here. I just made a little mount for it, but that's in the colour theme, so it's just going to mount up there and I can connect it to the parts I need to the back of it. So one of the things we're going to be doing is on the back of you've got the relays, the relay which the BMV can trigger, and that's what I'm going to be using for some of the safety cut-offs for the whole system. So I'm going to use the bistable relay on there. Bistable means when, I'm pretty sure it means when it's in one of its positions, it's not using power to keep it in that position, or not using much. So we're going to use the low voltage alarm, no, the high voltage alarm and the low temperature alarm to trigger the relay, which is then going to be connected to the pin, the remote on-off pins on both of these. So if for some reason one of those was giving out too much voltage, or there was too much voltage in the system for some reason, so let's say it went up to 16 volts for some reason, that would trigger the relay, which would trigger the on-off pins on those in the bottom corners, turning those off. Or the same for if it got really cold in the van and these batteries got down to 5 degrees, that would trigger the relay, and that would then trigger the on-off pins on these and turn them off. For getting temperature sensors, we're using this, which connects to the main positive on the battery. That then connects to the shunt, and the shunt connects to this. That's where this is getting its information from. So this is where this is getting its information from the temperature. Another thing is this can also speak wirelessly to this by the Victron smart network. This can't. So this has got an option for low temperature cut-off charging as well, so this could get the temperature information wirelessly from here, which is getting it from the temperature monitor, and turn off wirelessly. But because I'm going to have to use the low temperature trigger on the relay anyway, for this one I'm going to just have them both put in. As far as I'm aware as well, I don't see any issue with, although there's only one normally closed port on the relay on the back of there, I don't see any issue with paralleling that signal to go into both of those at the same time. So to make the cable, this is what goes into the back of the BMV, and which was the original power, but that's going to be replaced from the shunt side. I'm going to cut off this connector and add on my own.
Do you want this or do you want beer?
I have a beer. Oh, what do you want me to have?
It's up to you.
I have a beer, I think.
You want to try one of those chocolate ones?
Yeah, alright. Well, installing the temperature sensor, there isn't actually much to do. These two ends go into the shunt, and this goes to the main positive. So I'm just going to put that in now. I'm not going to bolt it on because that's going to go in when I fully connect up the batteries, but I'm just going to put this in now and do the cable management for it. Right, it's another new day, and the two connectors, the 16mm square cable to M8s have turned up, so I can now finish wiring up the Victron battery protect. So let's get that done. Right, moment of truth is to test all the batteries. So at the minute I've got the communications cable back in, and I did a whole video about how to get these batteries talking to the computer with their decade-old software. A few weeks ago, when I got them all separately, I charged them all up to a similar percentage, which fixed all the cell spreads. As there was a little bit, some of the cells inside the batteries had wandered a bit further away from different voltages from each other's. So I charged those up and I got those all fixed. Some of them were up to like 40 millivolt spread, and now they're all back down to 3 or 4s, and that's where they've been staying when they haven't been used the last few weeks. They're all generally at the same voltage. I'm just going to check to make sure. So they're all 0.02 of a volt from each other, which should be fine. The reason it's important to have them balanced is when they're running in parallel, which is what we're going to be doing, they're going to try and balance each other to make sure that they're all the same voltage. So if you've got a huge difference, these being lithium batteries, the lowest one is going to pull as many amps as they possibly can. The reason I wanted to have it plugged into the computer when I took them together, because I want to see what happens. So I'm going to set this to read the module 18, which is the lowest, of the three and see what happens, what current that sort of draws. So connecting them up, we need to connect the negative last, because the shunt wants to have that connection made last. To do it, these used threaded terminals. I'm using stainless steel bolts and a sprung washer. A mistake I made yesterday with the battery cables was I made 3 for 3 batteries when actually you need 2 for 3 batteries. Those are all the same length, so I'm going to start joining them up now. Before I do that, I've just pointed out that the master isolator is off, the appliance isolator is off, the DC to DC isolator is off, so everything is disconnected. Bring you a bit closer so you can have a look at what's actually going on. So you can see that one's giving current, well, that one's having current taken from it, and it's being wrong one, and I want number 18. We've got battery number 18, which is the lowest. It's currently charging itself off the other ones whilst they just equalise. Number 6, it's suddenly enough losing energy because it's the one which is having energy taken from it. And number 9, it's just sitting in the middle of the road, which I presume that's because what they're trying to equalise to, because it's generally in between. Well, that's what I'm hoping. Well, it appears they've all equalised, so I'm now going to connect back up to the shunt and bring the overall system online again. Right, so the monitors come on. Monitors come on, showing system voltage. Is that? So we've got the Victron app, just to be in V at the minute as I haven't turned the rest of the system on. Showing the voltage, and the temperature sensor is showing up. The batteries I've just changed to 390 amp hours at the moment. It's probably less than that, and I'll have to do some tests at some other point to figure out what the actual amp hours left is. But if we go here, and if I flip the switch, the rest of the system should power up. I'm going to put the DC to DC charger isolator on. So that voltage is the van's battery engine. So I need to change some of the settings. So these are now going to be to lithium. I am going to play around and play with these a little bit more with the absorption and float voltages. I think I will be lowering them a little bit. So I've been playing for a few days to try and get the remote trigger to turn on and off these devices. And so far I've had this turn off no issue with the relay from here, but this one won't do it, and I'm not quite didn't quite understand why. So I did some more reading, and yes, the on-off pins in this work the same, but this is an isolated unit, and this unit is powered by the van's battery, so the input battery, and not the output battery, which is the Leisure. So these were on 2 different systems, so I didn't enjoy having a 12 volt signal coming from this system through the relay, turn it off. So I did some looking up, and it turns out they actually make that part, which is a wire Victron make, which is the Orion isolated DC charger remote cable, designed so the DC to DC charger can be turned off by the system it's powering, not the system it gets its power from. So let's install that and see if we can get the triggers to work. The point of this cable is it's designed to be used with a BMS, so the yellow input, when it receives a signal, which I'm presuming and hoping means an input voltage, that then triggers the bit which goes into the device normally to switch off, or at least that's the plan. So we've got the wires all rigged up. I'm just going to go give it a quick test. So at the minute we've got nothing coming into the system, mainly because the batteries are full. But we can see the DC to DC charger is currently in absorption mode, and the solar charger is currently on and giving a little bit of voltage. that's really low just because it's sunny. There's no electricity to put into anything at the minute. So what we're going to do is we're going to fake trip one of the criteria for one of the safety features. So at the minute the batteries are 14 degrees. So we're going to go to the relay and we're going to just change the low temperature from 5 degrees, which will turn it off, to say 17 degrees. To put it to 17 degrees, the battery's this is going to trigger, realising the batteries are below 17 degrees, I have to turn the chargers off. So we've done that, and there should be about 10 seconds between it seeing the criteria for having to turn off and then turning off. So it's currently on. There we go, we just had the click there of the relay. Let's turned off the charger because the remote pin is inactive. And if we go on here, look at the solar charger, we can see that the charger is also off. It says it's been disabled by the remote or disabled by a BMS. So that's what we want. So we'll just go put that temperature thing back to normal. Back down to 5 degrees. And you just had it click again, and both of these should be now active again. There we go, and it's charging again. So the safety feature wise, we've got a low temperature trigger and a high voltage trigger, which is going to turn these chargers off. We're not using the low voltage relay, because if we use low voltage trigger it would turn the chargers off, and it's low voltage, we want the chargers to come on. If the Victron battery protect can sense the low voltage and then turn itself off. So that's all working. That's all the safety features installed into the system. Well, the later part of this video has been a bit techie and nerdy, so I hope everyone hasn't switched off. But some of the main things I had to do was not just reinstall the lithium batteries, but all the extra safety precautions I had to add. Because they don't have their own true battery management systems which can perform safety cutoffs such as under voltage, high voltage and low temperature cutoffs, I've had to build them into the system using mostly settings in Victron kit. So for the low voltage or under voltage, or effectively you've drained the battery too much, I've got the Victron Smart Battery Protect, and what that's doing is when that sees the system voltage reaches less than, I think I've got it set at the minute to 12 volts, for a small duration of time, it will then cut all the loads, because the positive on that is what all the DC loads are attached to, so that would stop the battery from draining some more. The other two options we needed to figure out were high voltage, such as for some reason the batteries become overcharged, let's say they've reached 14.6 volts, this is what I've got the system set to, and I needed a way to switch off the solar charger and the DC to DC charger. And the same way, I'm using that same system to turn off the chargers if there is a low temperature warning, as lithium batteries can't be charged in low temperatures as it can permanently damage them. So for the low temperature, we've got the temperature sensor for the BMV from the batteries, which goes to the shunt, and then the BMV smart monitor can talk to the MPPT solar charger and tell it to cut off, but we're not using that particular feature as it can't tell the temperature to the DC to DC charger, so we use the remote pins. And to do that I needed to basically wire the relay and the low temperature trigger to fire the relay, which was onto the remote on-off pins on both the devices. The DC to DC charger took a little bit longer to figure out because that gets its power from the van's main battery, not from the electric system, so I needed an extra little cable. But that all works, so when it gets below 5 degrees at the minute, it turns off the chargers. Even if I start the engine, the DC to DC charger won't fire and won't charge, and same for the solar panels. If the sun comes up but it's still cold, it won't charge the batteries. And the high voltage, when the battery monitor senses a high voltage, it does the same trip. It again fires that relay, which will turn the chargers off for both of those. The main bits I'm still playing around with are the float voltages and absorption voltages for these particular batteries, as they're not LiPo 4, they're they're lithium ion magnesium phosphate, slightly different chemistry, and they're old, and at the minute I'm finding the recommended batteries charge voltages aren't working out too well. They're really sort of pushing the batteries a little bit harder than they want to. So I've got them quite toned down. I've got a absorption voltage of 13.65, and a float voltage of a bit less, of I think 1338. Once again, a bit of a techie video towards the end. I hope there are still some people watching, but thank you very much for joining me. If you have any questions about the setup or anything else, find me on Instagram. A few of the subscribers have messaged me, and I get 1 or 2 messages every few days now, which is brilliant. Always happy to answer them as quick as I can. But yeah, and I will hopefully see you next time. Cheers, bye.